Okay, here we go. This is a specific heat capacity problem. In this case, Q is given. We're not solving for Q. Remember from the notes that does affect how we approach the problem. And I'll explain more at the end of the question too to show you what happened. Um, Here's what it reads, and I have already set up here my equation. It's Q equals M delta T Cp. That's the specific heat capacity equation. I've listed all my variables here, and now I'm going to read through the problem and see what I can fill in. The temperature of a sample of iron with a mass of 10.0 grams. So I know that this is 10.0 grams of iron. Changed from 50.4 degrees Celsius to 25 degrees Celsius. So this is my temperature change. Remember, temperature change is final minus the initial temperature. Okay, TF minus TI is what that says. Um, so from 50.4 degrees Celsius to 25 degrees Celsius, think about it. If you're going from here to there, you're going to get there as the last thing you do. So in this case, that means that the 25 degrees Celsius is the final temperature. I subtract the initial, so it started at 50.4 degrees Celsius. I punch that into the calculator here. All right, so 25 minus 50.4, and I get negative 25.4. Negative 25.4 degrees Celsius. And the thing I need to remind you guys is of significant figure rules when we're dealing with decimal points. This has no decimals. This has one decimal. That means the final answer can only have no decimals. It has to have the least amount of decimals. So 25.4, that 4 has no effect on the 5. So that ends up becoming just negative 25 degrees Celsius. Okay? And then it says with the release of 114 joules of heat. That is the energy value. That's Q. Okay? I'm going to write 114 joules here, but then I have to remind you, when Q is given, it's always listed as a positive value. Okay? The wording around it is what determines how you're going to list it right here where I just did. Okay? I just wrote the number. Okay? I look at the vocabulary, and the key word I pick up is release. Release means to give away or exit or move away. And that's when that happens, as far as heat's concerned, that means a negative energy value. So I assign this to be negative because that 114 joules is moving away. It's being released. Again, I assign the negative because of the wording of release right there. Okay, so let's continue. What is the specific heat of iron? And that's what they're asking me for, so now I know that that's what I'm looking for. Okay, so I've done all my initial groundwork, so now I move on to the next part. Okay, let me switch screens here so we can see a little better. All right, so I rewrite the equation, or not rewrite it. Here's my equation I'm working with. Okay. And the deal is I'm solving for Cp, this right here. The way the equation is written, it's not isolated for Cp. So what we recommend is that we isolate what we're searching for first, and then we substitute the numbers in. That way there's less mistakes when you move the numbers around. So in order to get rid of the m delta t with the Cp, I divide both sides by m delta t, and this is something you should have covered in algebra. It's not a chemistry thing. This is a math thing that I'm doing here. Okay, and when I do that, these are going to cancel, 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 and I get q over, well, that's a fancy q there, over m delta t, and that equals to Cp. Okay, I feel more comfortable with my unknown being on the left side, and that's the only reason I rewrite it. It just makes me feel a little more comfy. Q over M delta T. Okay, so now I've isolated the unknown variable by itself, and that's what you're supposed to do in step 2. Okay, and I also need to confirm that I'm in the right units, and in this case I am. Joules is appropriate, grams is appropriate, degrees Celsius. If it's ever anything other than those three, you got to convert back to joules or grams or degrees Celsius. There's a few times we throw it to you a little differently, but for the most part, as long as you're aware, you should be okay. All right, so now I go to step 3, which is my favorite step. Step 3 is the plug and chug. This is where we're just going to substitute all the hard work you just did, and we're really just solving the problem. Okay, so here we go. Q, okay, let me scroll that up a little. Q, you guys designated as negative 114. So I'll write that there, negative 114 joules over the mass. The mass is 10.0 grams times delta T, negative 25 degrees Celsius. And so it looks like that. And now I just punch it into my calculator. So let's do that. So the top is negative 114 divided by, oops, that's too much. 114 divided by, and then I open parentheses so I can do the bottom. I want to multiply the bottoms together, so the way I ensure that is to I put that inside a parenthesis. 10.0 times negative 25, and then I close parentheses, and I hit equals, and I get 0.456. 0.456, and unit-wise, nothing cancels. Okay, nothing gets to cancel, so I just leave it. Joules over gram degrees Celsius, and you'll probably remember that is the specific heat capacity unit, so it looks like we're in the right spot. Last thing I need to show you guys, remember sig figs still play a role. This is all multiply and divide, so I just count. 3 sig figs, 3 sig figs, 2 sig figs. That means my final answer can only have 2 sig figs. Okay, so I'm going to cut right here. And then that's going to talk to me about what that one does. And I get 0.46 joules per gram degree Celsius. And that's a great final answer. If that's what you obtained as your final answer, that's a good job. Okay, 0.46 joules per gram degree Celsius. Now, let me explain something that we talked about earlier. So if I'm going to scroll up here, I'm going to make a little arrow from the Q, and I'm going to explain what happened. All right, and that's going to go somewhere to right there. Let me scroll this up. Okay. So let's talk about this. All right, and I'm going to say since Q given, okay, since the Q is given, the wording in the problem, I want to make sure I say this right to you guys. The wording in the problem tells you sign of Q. The wording in the problem tells you the sign of Q. Okay, so the problem said, let me write this in purple so it stands out a little more. It says release of 114 joules. Okay, that's the exact wording that the problem uses. Okay, so this word right here, release, means move away. Okay, an energy release means you're moving away, so therefore assign to be negative. Okay, because when energy moves away, negative, and so you wrote it as negative 114 joules. Okay, that's why it's assigned as negative 114 joules. Okay, hopefully that helped you guys. We'll talk to you again. We'll do some more of these problems in class. All right, hopefully this helps. Talk to you guys soon.